Okay, so if you could take out your Unit 2 packet, we're going to start that in this video. Okay, so if you open it up, you'll see the first examples are on page 3. We're actually not going to do these examples together in this video. We're going to save that for tomorrow, okay? We're going to do those ones in class. So if you could actually backtrack a page, you'll see there's a blank page, okay? It's on the back of the cover sheet, so it's page 2. That's where we're going to write down the examples that we're going to do in this video. Okay, so we're on the blank page. It looks just like this. We're going to do a total of 3 examples. If you have very big handwriting, you may want to take out a separate sheet of paper. And you could do it on a separate sheet of paper, but make sure if you do that you take that paper and you put it in your binder. Or if you have an accordion folder instead, this would now go in the second section of your accordion folder because we're on Unit 2. Okay, so I actually just copied a picture of the directions from the next page up at the top here because these are the rules we're going to follow. You don't have to copy these down because they are on the next page, but I would like you to copy down example 1. So what we're doing here is we're solving this equation for x. Okay, so if you want to solve an equation where the degree, okay, which is your biggest exponent, is something other than 1, these are the steps that we're going to follow. Okay, so if your biggest exponent is a 2, a 3, a 4, whatever it is, we're going to follow these steps. Okay, so step 1, set one side of the equation equal to 0. Okay, now I know in the past, if we want to set one side of the equation equal to 0, right, we would subtract 32 from both sides of the equation. So if you want to write minus 32 and minus 32, you can. But at this point in math, I mean, you could just take the 32 and bring it to the other side of the equation. And when you do, right, since we're really subtracting it over, doesn't it become a negative 32 on the left-hand side? So what I'm going to do is I'm going to bring down my 2x squared. I'm going to bring down my plus 12x. And if I were to subtract this 32 over, it would become a minus 32. And then I'm going to bring down equals 0. Now again, I didn't show this, but if it helps you to write minus 32, and then these cancel, right, to give us 0, and then we just throw the minus 32 at the end here, you can write this. But again, at this point in math, if you're just taking this 32 and bringing it over, the sign changes, right, to a minus 32. Okay, now step 1 we're done with. So let's go to step 2. Step 2 says factor the expression. All right, so we know how to factor, right? We did that in the entire last unit. So if we want to factor this, we want to look at all 3 of these terms and say, well, first, can I pull out a greatest common factor? And yes, I can. I can pull out a 2. So let's do that. So if I pull out a 2, that'll leave me with x squared plus 6x minus 16 equals 0. Okay, now because it's an equation, you want to make sure you keep it an equation. This equals 0 is very important. Okay, you want to keep writing it. Don't forget about it, because if we forget to write this, it's just an expression. Okay, now, inside our parentheses here, right, we have a trinomial. And because our leading coefficient is 1, we're going to use the AM method. Right, we want to say what 2 numbers add to 6 and multiply to negative 16. Now, I'm going to worry about that in a minute. Why don't I first take this GCF and bring it down. I'm going to open up 2 sets of parentheses. And since this is an x squared, I can put an x and an x. And I'm going to bring down my equals 0 now because I don't want to forget about that. Okay, now, 2 numbers, let's think about this, that multiply to negative 16 and add to positive 6. Wouldn't that be positive 8 and negative 2? Okay, so here I finished step 2, factor the expression. I factored this expression as much as I could. Now it says set each factor equal to 0 and solve. Okay, so we have 3 factors. 2 is one of our factors. X plus 8 is another factor. And x minus 2 is the third factor. These are our factors because if I were to multiply these together, right, these would multiply together to give us this original expression right here on the left-hand side of the equation. Okay, but anyway, step 3, set each factor equal to 0 and solve. Okay, so I'm going to take this 2, right, our first factor, and set it equal to 0. If you want to separate your factors, you can. Okay, then I'm going to take the x plus 8 and set that equal to 0. and I'll take my x minus 2 and set that equal to 0. So I'm taking each factor and just setting it equal to 0. And not only do I have to do that, but I have to solve these. Now, let's start, actually, I'm going to start with the middle one, x plus 8 equals 0. If we want to solve that, wouldn't we just subtract 8 from each side of the equation? Again, I'll do this in pink. If you want to show minus 8 and minus 8, right, you can. But basically what's going to happen is, like, aren't these positive and negative 8 going to cancel? So I bring down the x, and then isn't 0 minus 8 just negative 8? So if it's easier for you to see, right, if we were to just have taken this 8 and moved it to the other side of the equation, it becomes negative. You don't have to show this work in the middle here, okay? So same thing with this one. Let's look at x minus 2. If I want to solve that, right, technically I could just take this minus 2, move it to the other side of the equation, and it leaves me with x equals positive 2. If you want to show plus 2 and plus 2, right, and these cancel, and then 0 plus 2 is 2, you can. But again, at this point in math, you don't have to show this. Okay, you could just jump right to the answer. You don't have to show this middle step. Okay, now, I skipped over this one because this one was a little unique. It says 2 equals 0. Now let's think about this. Does 2 equal 0? No, not at all, right? 2 is 2 and 0 is 0. They are not equal to each other. So what we're going to do is we're going to cross this out because this doesn't make sense, all right? So here we want to put two solutions. X equals negative 8 and x equals positive 2. So we can either circle them, or sometimes if you want to write them in a solution set, you can write it like this. In curly brackets, you could put negative 8 and positive 2. So this is our answer. Now, see how here this was the biggest exponent is at 2? We call that a second degree equation. The degree of the equation tells you the maximum number of answers that you're allowed to have. So if we have a second degree equation, we're going to have a maximum of 2 answers. Okay, now, so if you can copy down example number 2, and again, I just put the steps up here just so we wouldn't forget them. Okay, so step 1, we're going to go a little faster this time. Set one side of the equation equal to 0. Okay, so this 30x, I'm going to move over to the other side of the equation, and when I do, the x cubed stays positive, the 7x squared stays positive, and when I move this 30x over, right, to the other side of the equation, I'm technically subtracting it, so its sign is going to change. It's going to say minus 30x. And then I can bring down the equal 0. Okay, just to visually see that, for some of you that like to see it, all I did was I subtracted 30x from both sides of the equation. Okay? And you don't have to write what I'm writing in pink. Okay, so now we're on to step 2. Step 2 is to factor the expression. So we're factoring this expression on the left side of our equation. All right, so again, our first step is to factor out a greatest common factor. Okay, so let's do it. We can pull an x out of each term. So that leaves me within the parentheses x squared plus 7x minus 30 equals 0. Okay, so all I did was I factored an x out of each of these terms. Now, if we look within the parentheses, we have a trinomial again with the leading coefficient being 1. Okay, so we're going to utilize the AM method. So first, let's bring down this x. Let's open up 2 sets of parentheses, and don't forget that equals 0, right? Put that at the end. And since this is an x squared, again, we're going to put an x in the first spot in each parenthesis. Okay, so 2 numbers that multiply to negative 30 and add to positive 7 would be positive 10 and negative 3. Okay, so we've finished step 2. On to step 3. Set each factor equal to 0, and then we're going to solve. So if you want to divide these, if you want to separate them so they don't all blend in, you can. You can go like this. You can put a line to separate this if you want. Okay, so here we're going to set our first factor, which is x, equal to 0. Then here we're going to set our second factor, which is x plus 10, equal to 0. And then let's set our last factor, x minus 3, equal to 0. Okay, so this time I'm going to start here. It says x equals 0. Well, can x equal 0? Yeah, it sure can, right? X can equal lots of things, and in this case, x does equal 0, because think about it. If you went back to this original equation and replaced all these x's with 0, right? 0 cubed plus 7 times 0 squared, isn't that just 0? And over here, 30 times 0, isn't that just 0? So if you replace each of these x's with 0, this equation would check. So x equals 0 is actually one of our answers. Okay, now off to this one. If you subtract 10 from both sides of the equation, or if you want to take this positive 10 and move it over to the right, you're going to wind up with x equals negative 10. Again, if that's hard for you to do, you could, I'm going to do it in pink. You do not have to write this if you could visually see what I just did. You could subtract 10 from both sides of the equation. So these cancel, and 0 minus 10 is negative 10. Okay, so that's another solution. And then finally right here, right, if I solve this, I could just add 3 to both sides of the equation, or when I move this to the other side of the equation, it becomes a positive 3. So I get x equals 3. And again, let me do that in pink for whoever needs that. I can add 3 to both sides of the equation. So these cancel. I bring down the x, and 0 plus 3 is 3. Now here, if you notice, we wind up with 1, 2, 3 solutions. And if you look at the degree of the equation, right, the biggest exponent is a 3. So that tells us we could have up to 3 solutions. Okay, sometimes you'll see you have a repetitive solution where these wind up being the same exact number, right? When you, like, if your factors are the same, your solutions are going to be the same, and that's when you wouldn't have the number of solutions as the degree of the equation. Okay, so this time I'm not going to put the steps at the top of the page because we're going to see if we remember them. Okay, so step 1. What is step 1? That's right, we want to set one side of the equation equal to 0. So in order to do that, I'm going to take that negative 9 on the right side of the equation and move it over to this side, and when I do, it becomes a positive 9 because technically I'm adding 9 to both sides of the equation. Okay, now this time when we look, there's no greatest common factor to factor out. And look at this, the number in front of our first term, right? We call that the leading coefficient, is not a 1 this time. So this time, we're going to have to do the rainbow. Okay, we're going to multiply together the first and last term, so that gives us 36. Okay, now when we do the rainbow, you bring down the first term, leave a big space, and bring down the last term. And don't forget the equal 0. Okay, so this time we're coming up with two numbers that add to 12 and that multiply to 36. So that's actually pretty easy, right? 6 and 6. All right, so we're going to write plus 6, and don't forget to put that x on it, and then plus another 6x. Okay, so now we're going to do our grouping. So out of the first two terms, I can factor out a 2x, which is going to leave me with 2x plus 3. Okay, now out of the last two terms, I could factor out a 3. And that's also going to leave me with a 2x plus 3. Right, just to show you, 6x divided by 3 is 2x, and 9 divided by 3 is 3. And what did I forget to do? That's right, bring down the equal 0. I want to keep it in equation. Okay, so now I'm going to take the 2x and the plus 3, right, these two terms that are in front of our common parenthesis, and I'm going to group them together to become my first factor. Okay, then I'm going to take the common parenthesis, what's in common? The 2x plus 3. Oop, I forgot to close that. I'm going to take the 2x plus 3 and rewrite that once and once only, and bring down my equal 0. Now, what you might notice here, look at this. Our two factors are the same, right? So, didn't we say in step 3 we want to set our factors equal to 0 and solve? Okay, if you want to separate them like this, you can. So I'm going to write 2x plus 3 equals 0, and I'm going to solve. Now over here, I don't have to write 2x plus 3 equals 0 and solve, because aren't I going to get the same exact solution that I did here? So if it's going to be the same solution, why write it twice? Okay, now in order to solve this, right, the first thing I'm going to do, again, I'll put it in pink, but you do not have to write this. Minus 3 and minus 3, right? So that's going to leave me with 2x equals negative 3, right? Because these cancel, and 0 minus 3 is negative 3. You do not have to write this. You could just move the 3 over and make it negative. Now to get rid of the 2 in front of the x, 2 times x. The opposite of times, the opposite of multiplication is division. So we would divide both sides by 2. Again, you do not have to show this. If you don't want to show divided by 2, and show these cancel, you don't have to. Basically, right, you could just bring down this x, and in your head, just know if I take negative 3 and divide it by 2, it's going to give me negative 3 over 2. So if you don't want to show the pink steps, you don't have to. So here, this is my solution, x equals negative 3 over 2, or x equals negative 3 halves. Okay, since this is the same factor, we get the same solution. We do not have to write it twice. So if you want to write your solution in curly brackets like we did with the first one, you could write negative 3 halves. We could have done that with the second one as well. Now I want to point out, here, this is a second degree equation. This tells us the maximum number of solutions we can have. So we could have 2 solutions in total. But look at this, we don't this time. We only have 1, and that's because we have a repetitive solution. So in this case, the number of solutions does not match up with the degree of the equation. And that happens sometimes.